Okay, so you've sent over all these slides about lenses and mirrors.
Yeah,
And it's a lot.
it
It's
is.
like this whole crash course in how light interacts with the world.
Yeah.
What specifically caught your eye in all of this?
You know, it's funny. We walk around, we see lenses and mirrors all day, every day, and we don't think about them.
Right.
But they play this really important role in how we understand the universe. And so I think this deep dive will give everyone listening a good grasp on how they work, and they might be surprised by the unexpected places that these principles are at play.
I'm intrigued already.
Yeah.
Okay, so these slides, it looks like we're starting with lenses.
Yeah.
What's the game plan there?
Let's break down lenses in a way that's easy to understand. So think about those curved pieces of glass or plastic
All right.
that you see in eyeglasses or cameras, telescopes, even our own eyes.
Right.
We're going to go through the basics of what they are, how they work,
Okay.
and then we'll look at some real-world applications.
I love it. Okay, and we've got this great image here of a magnifying glass over a book. Classic example, right?
Yeah, absolutely. The magnifying glass is a really good example of a convex lens, which, as you know, is thicker in the middle and thinner at the edges. It makes things look bigger by bending those light rays inward right into a single point.
So if a magnifying glass is a convex lens,
Right.
what is a lens? Like in the most basic terms.
So at their core, a lens is really just a piece of transparent material, usually glass or plastic. But the key is that it's curved on
Yeah.
one side, both sides. And this curvature, it allows for the lens to bend light. And that bending is called refraction.
Yeah.
And it focuses light rays in specific ways. And that bending and focusing allows for objects to appear larger or smaller or clearer, depending on the lens.
Okay, so it's all about the bend.
Yeah.
Now, I know we have two main types of lenses. We have concave and convex.
Right.
We talked about convex lenses a bit. But how are concave lenses different?
Another great question. So, unlike a convex lens, which converges light, concave lenses are thicker at the edges and thinner in the middle. And this actually causes the light rays to spread out or diverge as they pass through.
So a concave lens would be like the opposite of a magnifying glass?
Exactly.
Things would look smaller?
Yes,
Okay.
exactly. And this is actually why concave lenses are used in eyeglasses for nearsightedness. It's also called myopia.
Okay.
And so they actually help to adjust the way the light enters the eye so that the image focuses directly on the retina.
That makes sense.
Yeah.
Are there other places that we might find concave lenses?
Yeah. So if you think about a peephole in your door,
Okay.
that peephole is actually a concave lens because it gives you a wider field of view.
Wow.
So you can see more of who is at the door without them seeing you.
Such a simple concept, but so important for
Yeah.
safety.
For safety.
What about other applications?
Concave lenses are also used in flashlights.
Okay.
So the concave lens sits in front of the bulb and it helps to spread the light beam so that you can illuminate a larger area. Yeah. They're also in telescopes. It sounds counterintuitive, but telescopes actually use concave lenses with other lenses to improve image quality. And what they're doing is correcting for distortion. And then lastly, you'll find them in cameras too,
Oh, wow.
because they help to widen that field of view. So when you want to get those really big landscape shots,
Right.
they're helpful for that.
So many different applications for something that bends light outward.
It's true.
That's wild.
Mhm.
Okay, I think this is a good time to talk about the images formed by all these lenses because we keep hitting on this concept of a virtual image.
Yes.
What's the deal with a virtual image?
So a virtual image is one of those things that it's hard to wrap your head around, but basically it's an image that cannot be projected onto a screen. It's only an image because of how our eyes and our brains interpret the path of light rays.
Okay.
It's really kind of an optical illusion in a way.
So that's why you can't take a photo of what you see through a magnifying glass.
Exactly.
Because it's not actually there.
Yeah.
It's just...
It's not a real image. It's just how our brain is interpreting it. And concave lenses, like we see in those peepholes, always form virtual images that are upright. They're not flipped upside down, and they're smaller than the original object.
Okay, back to convex lenses for a second, the thicker in the middle ones.
Right.
We touched on magnifying glasses, but what else should we know about them?
So convex lenses are interesting because they can actually form two types of images.
Okay.
They can form real images and they can form virtual images. We just talked about the virtual images with concave lenses. A real image is one that you can project onto a screen.
Yeah.
So if you think about a projector,
Right.
a projector uses a convex lens and it creates that image on a screen. So that would be an example of a real image.
So the big difference is with a real image, those light rays, they actually converge
Yes.
at a specific point in space.
Exactly.
So theoretically, you could put like a piece of paper there and you would see the image versus a virtual image where it's more of our brains tricking us
Yes.
into seeing an image.
Exactly. Another thing about convex lenses is that the real images that they form are always inverted,
Okay.
but the virtual images are upright.
So the image on the screen is actually upside down.
It is.
That is so wild.
But that's why we have brains.
Right.
Because our brain takes that information and flips it right side up so that we don't even realize that we're looking at something upside down.
That's incredible. So
Yeah.
where else do we encounter convex lenses in our everyday life?
So in addition to a magnifying glass, convex lenses are used in eyeglasses, but for farsightedness this time.
Okay.
They're also used in cameras and telescopes.
Oh, right.
And they can be used to make images larger or smaller depending on their curvature and how they're being used.
Cameras are a great example because they use that convex lens to focus the light onto a sensor to create that real image, which we can then print or share digitally.
Right.
But you can't do that with a mirror. You can't project what you see in a mirror
Right.
because that's a virtual image. It's so cool how it all comes back to the shape and how that bends the light rays. But also, this is blowing my mind. Did you know our eyes have a natural convex lens in them?
They do.
That's so cool.
It's amazing. Our eyes are incredible. They really are like their own little optical instruments. And the lens in our eye sits right behind the pupil, and it focuses light onto the retina, which is in the back of the eye.
It's incredible how our bodies are just doing these things and we don't even realize it.
Right.
And I remember learning that the lens in our eye can actually change shape.
It can, yeah. It's called accommodation.
Right.
And this flexibility allows us to adjust our focus to see things at different distances.
Okay.
But as we age, unfortunately, our lenses become less flexible. And that's why a lot of people need reading glasses.
So those reading glasses are adding another convex lens to help the eye out.
Exactly. They're helping to compensate for the eye's lens.
Wow. Okay, so we know convex lenses can help us see, but what about some of those other applications? I know microscopes use them, right?
Yeah, microscopes are a great example because they're using those convex lenses to magnify very, very small objects, making them appear hundreds, sometimes even thousands of times larger than they actually are.
Oh, wow.
Which allows scientists to see individual cells and microorganisms and things like that.
It's just crazy that something so small can have such a huge impact on how we see and understand the world.
Right.
What about binoculars? I know they use convex lenses as well.
They do. They use a system of convex lenses to magnify distant objects, essentially bringing that object closer.
Okay.
So we can see it in greater detail.
It's like a window to the world around us.
Exactly.
Okay, and then projectors, like the one we probably use to show these slides to each other,
Right.
use convex lenses as well.
They do. So they're shining light through a transparent image, and then that convex lens is creating a much larger version of that image on the screen.
Wow. Okay, so from the tiniest cells to the images on the screen, these convex lenses are really shaping our view of the world.
They really are.
What about telescopes?
So telescopes use convex lenses, sometimes really, really large ones, and they collect and focus light from distant objects in space.
Right.
And without telescopes, we wouldn't even know about galaxies and nebulas and things like that.
It's really incredible to think about the impact that these fairly simple instruments have had on our understanding of the universe.
Yeah, they have. They changed everything.
Okay, fantastic deep dive on convex lenses.
Yeah.
What about mirrors?
And mirrors, just like lenses, have a fascinating story.
Right. Before we even get to all the specifics,
Yeah.
did ancient civilizations even have mirrors?
Yeah.
Or, like, what did they use before manufactured mirrors?
I love this question. So the very first mirrors were actually just pools of water.
Oh, wow.
They were naturally reflective surfaces.
Yep.
And so ancient civilizations would actually look into these pools of water to see their reflection.
Wow, that's wild. Okay, so when did we start to see those first manufactured mirrors?
So as early as 6000 BC, we start to see manufactured mirrors that were made of polished stone. Things like obsidian or pyrite.
Wow.
I mean, can you imagine the craftsmanship
It's amazing.
involved in creating a smooth, reflective surface from a rock?
I can't imagine. It makes you appreciate the art behind the science.
Absolutely.
So polished stone, that was the first step. What came next?
So if we fast forward a few thousand years to about 4000 to 3000 BC,
Okay.
we start to see metal-coated mirrors.
Okay,
These were made of bronze, tin, or silver.
cool.
And they were more reflective than the polished stone, but still not quite the mirrors we have today.
Right, right. Okay, so we've gone from pools of water to polished stone to metal.
Yeah.
This is bringing us a little
Well, it's
closer
getting
to
closer.
the modern mirror. When does glass come into play?
This was a huge moment. Around the 1st century AD, we start to see glass mirrors that have these metallic backings.
Wow.
And glass was a game changer because it offered this smooth, consistently reflective surface.
That makes sense.
Hmm.
And that led us to the modern glass mirrors we have today.
It did.
The ones with the silver backing.
Yeah, that very thin layer of silver.
Very cool.
Yeah.
It's amazing how something that we completely take for granted has this long history.
Absolutely.
Okay, so speaking of these modern mirrors, what actually goes into making one?
It's pretty cool. A modern mirror is made up of a thin sheet of glass,
Okay.
and then behind that glass is a primer layer, and then a very, very thin layer of silver.
Okay.
And that silver is applied through a process called electroplating.
Cool.
And this silver layer is what makes the mirror so reflective.
So it's really the silver that's doing all the work
The silver is doing a lot of the work.
of reflecting that light.
It is, but there's other layers.
Right.
So on top of that silver, there's a protective coating
Okay.
that prevents the silver from tarnishing,
Okay.
and then a backing paint, which adds durability.
Wow. Chemistry and engineering
Yeah.
happening behind the scenes of our mirror.
Who knew?
Okay, I want to dive into some of the physics now.
Yeah.
I know we have different types of mirrors to talk about, and I remember this term from school. The optical axis, what is that?
It's been a while probably since you've thought about that term.
It has.
But basically, the optical axis is this imaginary line,
Okay.
and it passes through the center of the mirror's curvature.
Right.
And we use it to understand how light is interacting with the mirror.
Got it. So the optical axis is kind of like our reference point.
Yeah.
Okay, so let's talk about the different types of mirrors.
Okay.
Starting with the most familiar plane mirrors.
Okay.
Just a flat mirror.
Yeah, the one in your bathroom.
Exactly.
It's a flat, smooth surface, and it's designed to reflect light.
Right.
And so when light hits that plane mirror, it bounces off at the same angle,
Okay.
and we call that the law of reflection.
Okay.
So the angle of incidence, how it hits, equals the angle of reflection.
Got it. But why is our reflection flipped?
Great question.
It's kind of trippy.
It is. It's very trippy. It's because the image in a plane mirror is what we call laterally inverted.
Laterally inverted.
And what that means is the image is flipped horizontally, but not vertically.
Okay.
So left to right, but not up and down.
Got it. So if I raise my right hand, my reflection raises their left hand.
Exactly.
It's not actually a perfect replica of me. It's laterally inverted.
You've got it.
Cool. So that image is virtual, right?
It is. You're on a roll.
Like we talked about with the lenses.
You got it.
It appears behind the mirror
Yeah.
at the same distance,
Yeah,
but we couldn't put a screen behind it and actually capture that.
you got it. Because it's not physically there.
Our brains are being tricked.
It's true.
Okay, so plane mirrors,
Yeah.
virtual laterally inverted image.
Yes.
What about those curved mirrors, the concave and convex?
Okay.
Let's start with concave. What's the deal with those?
Concave mirrors are where things get even more interesting.
Okay.
So unlike a plane mirror, which is flat, a concave mirror actually curves inward,
Okay.
like if you think about the inside of a spoon.
Gotcha.
And so because of that inward curve, it causes the light rays to converge after they reflect.
So the opposite of the concave lens.
The opposite.
When those rays are diverging, here we're bringing them together.
Yeah, and we call that converging point the focal point.
Gotcha. So that focal point is where all those rays are meeting up.
Exactly.
Okay. Now, are the images formed by concave mirrors always virtual?
This is what's cool about concave mirrors. They can actually form real and virtual images,
Oh, wow.
depending on where the object is in relation to that mirror's focal point.
So with concave mirrors, we can get real or virtual images depending on where that object is
You get.
in relation to the mirror.
So it just depends. Is it closer to the mirror than the focal point or further away?
Okay, so more nuance.
Way more nuanced.
Not as easy as just saying concave mirrors always do this.
Right, exactly.
Okay, so where do we see concave mirrors out in the world?
So many places. Think about a car headlight.
Oh.
They're using a concave mirror
Okay.
to focus that light from the bulb into a beam,
Oh, okay.
which is why they seem so bright.
That makes a lot of sense. What about those little mirrors that dentists use?
Yeah.
Those have that concave shape.
You do, because it gives them a magnified view
Right.
of your teeth.
That's so cool. And telescopes
Yes.
use concave mirrors as well.
Some of the most powerful telescopes are using these huge concave mirrors
Wow.
to collect and focus that light from distant galaxies.
It's like we're using these mirrors to unlock the secrets of the universe.
We are.
That's amazing. Okay, so we can't forget about convex mirrors.
Right.
Those are the ones that bulge outward.
Yes, like a security mirror
Yes.
that at a store.
Okay.
So they curve outwards, and because of that, they cause the light rays to diverge.
Okay, so it's the opposite.
It's the opposite of the concave mirror.
Gotcha.
And so what that means is that they always produce a virtual image
Okay.
that's upright and smaller than the original object.
Okay, and that's no matter where the object is.
Doesn't matter where the object is, yep.
So those security mirrors, they're
Yeah.
making things look smaller on purpose.
Yeah, it's all about
Why is that helpful?
field of view.
Okay.
Because the objects appear smaller, they can actually capture a much wider angle,
Oh, that's really
so
interesting.
you can see more of what's going on.
So it's like a trade-off.
It is.
Things might look smaller,
Right.
but you can see more.
You can see more.
And where else is that useful? Besides those security mirrors,
Well, if you think about it, a car's side mirrors,
right?
they're convex.
They are.
And it's so that you get that wider view of the road behind you
It's amazing how we're using all these principles of physics
every day.
in our everyday life, and we don't even realize it.
Right.
Okay, so we've covered so much.
I know.
We went from ancient reflecting pools to telescopes to car mirrors.
It's amazing.
What is the biggest takeaway for you?
You know, I think it's so easy to think about lenses and mirrors as just these scientific curiosities.
Right.
But really, they're part of our everyday life.
They really are.
They're shaping the way we see the world.
Absolutely. It's like we've just scratched the surface here.
Right. And the exploration doesn't end here. There's so much more to learn.
It really is like we're just starting to understand light.
We are.
This has been a mind-bending deep dive
No, this is fun.
into the world of lenses and mirrors. Thank you so much for joining me.
My pleasure. Until next time.